So now let's see how we can put this all together into an area calculation. So what we're going to do is we are going to use the right endpoint formula to find an expression for the area under the curve. And then we're going to take the limit as n goes to infinity, and we're actually going to get the exact area. All right, so we're going to do a pretty nice one, just f of x equals 2x on 0, 3. So what are we actually doing here? We're just looking at f of x equals 2x. So from 0 to 3. And so let's say that. And this obviously, if this is f of x equals 2x, then this would be 6 up here. So we're really just asking for this area here. And so we'll probably be able to check that pretty easily, see if we did it right in the end. Okay, so what do we need? Well, again, what we're going to do is we're going to end up getting this area as the sum I equals 1 to n f of, so if we're going to use the right endpoint, it's going to be a plus I delta x times delta x. Okay, so we have to build this whole expression. Well, I'm sorry, this would be approximately, and then the actual area would be if we took the limit as n goes to infinity, that's an n, of this whole expression. So we're going to need some things like delta x, that's b minus a over n. In this case, that's 3 minus 0 over n, or 3 over n. And then a plus I delta x would then be a is 0 plus I, and we just found delta x to be 3 over n, so it's 3i over n. Okay, so let's fill that out. The limit as n goes to infinity of the sum I equals 1 to n, f of a plus I delta x is 3i over n times delta x, which is 3 over n. So the only thing I haven't done is I haven't applied our function f there. Oops. So what does that mean? Well, that means that f, if we're doing this summation, I equals 1 to n, f is 2x. So I'd really just be doing 2 times this thing. So I get 2 times 3i over n, and I still have the 3 over n as the delta x. So I get the limit as n goes to infinity, the sum I equals 1 to n. And so what did I get all in there? I get 2 times 3 times 3, so I get 18i over n squared. All right, so if we just evaluate that, we'll get our area. Well, this is what we were doing before. So limit as n goes to infinity. I'll take out the 18 over n squared, sum I equals 1 to n of I. Again, that's one that I know. So it's the limit as n goes to infinity, 18 over n squared, and then this is just n times n plus 1 over 2. So I get the limit as n goes to infinity, 18 over 2 is 9, and then inside I would get one of the n's canceling, so I get n plus 1 over n. Just like before, the limit of 9 is 9 times the limit of this expression, that's n to the first over n to the first, so go in front, 1 over 1. Remember, we're doing limit as n goes to infinity, so we get 1 and we get 9. So I'm saying that the exact area of that region is 9. Now that shouldn't be that surprising. Look at this. This is a triangle, with base 3 and height of 6. So its area by geometry would be 1/2 base times height, or in other words, 1/2 3 times 6, 1/2 18 is 9. Just convincing us that, hey, it seemed to work out. All right, so let's do another example on this worksheet here. Let's do it for 16 minus x squared from 1 to 3. So I'm going to start by sketching it just so we have an idea of what we're looking at. Remember, 16 minus x squared, that would just be a parabola that's facing down. And 16 up here, this would be 4 here, so we'd really just be talking about basically 1, 2, 3, so 1 to 3 there. So this region right in here. So, where this is 16 minus x squared. So that's the region that we would want. So let's see how we can do this. Again, we're just going to use the basic idea that area is the limit as n goes to infinity of the sum I equals 1 to n. And I'm going to use the right endpoint, so f of a plus I delta x times delta x. Let's figure out the key things we need. We need delta x, b minus a over n, 3 minus 1 over n, 2 over n. A plus I delta x, now this time a is 1, so 1 plus I times 2 over n. That's going to be 1 plus 2i over n. Okay. Let's put that back into our formula here, our area formula. Sum I equals 1 to n, f of this a plus I delta x, 1 plus 2i over n, times delta x, which is 2 over n. Now, notice, next thing I need to do is apply what this function is. Whoops, I forgot my summation. The summation of f of 1 plus 2i over n. But f is 16 minus x squared. So we're really talking about 16 minus 1 plus 2i over n all squared, then times 2 over n. This is the sum I equals 1 to n. Okay, so we have to work out quite a bit here, algebraically. Be the limit, the summation I equals 1 to n of, 16. Okay, so what are we going to get here? So if we square this whole thing inside, so what's this thing going to be? Inside here we're going to end up with a 1 plus twice 2i over n, so 4i over n, plus 4i squared over n squared if I multiplied that out. Meaning that when I do 16 minus that, I'm going to get the 16 minus 1 is 15. Then I'm going to get the minus 4i over n minus the 4i squared over n squared, all times 2 over n. Okay, so quite a mess. And what I'm going to have to do is really break this apart so I can manage it. So I equals 1 to n. So I'm going to do the 2 over n times this. So I'm going to get 30 over n minus sum I equals 1 to n. Go to the next one. I'm going to get 8i over n squared minus sum I equals 1 to n. Then I'm going to get 8i squared over n cubed. Alright, so then once I have that, I know that I can then take out constants, so 30 over n, sum I equals 1 to n times 1, minus 8 over n squared, sum I equals 1 to n of I, minus sum I equals 1 to n, nope, take out the 8 over n cubed, sum I equals 1 to n of I squared. And then I use my formulas. Oops. 30 over n. This one here, remember, sum of a constant, that's going to give me 1n. So I'm just going to get n. Whoops, I want to go back to blue. N minus 8 over n squared, the sum of I, that's n plus 1 over 2, minus 8 over n cubed. I squared gives me just, so that's actually n plus 1 times 2n plus 1 over n squared. No, back that up. I used the wrong formula there. That's going to be n times n plus 1 times 2n plus 1 over 6. Sorry about that. All right, so when I use that, I'm going to get 30 minus, what do we get here? One of those n's, I'm going to get 4, and then n plus 1 over n, minus 8 over 6 is 4 over 3, and then I'm going to get one of the n's cancel, so I get n squared. And then notice on the top, if I multiply this thing out, I would get 2n squared plus a bunch of other stuff, but that's not really going to matter because I have n squared over n squared. So when I go and do the limit now, I'm going to get 30 minus, this is just 1, so I get 4, and the limit of this is just 2, so I get minus 4 thirds times 2, so I get 30 minus 4, which is 26, minus 8 thirds. I would end up with 70 thirds as my answer. And there I was able to actually find this area by that limit method. 70 thirds. A lot of work, yes, but I found it.